Welcome to algorithm video series. In the previous tutorial we discussed lower bound problem. Today in this tutorial let's talk about the logic behind the lower bound problem and its solution. Input here is a sorted list with duplicates and a target element. Output is first position where target can fit in a sorted list. Here remember we are searching for the position, not the target element. If target element is not present in the given list of numbers, then also we'll get the output. So here we have a sorted list with duplicate elements, right? If I want to find the lower bound of target element 20, then what I need to do is I need to ignore all the elements which are smaller than the target element. Here 10 is smaller than 20. That is our target. So we need to ignore this. Next, we need to compare this element. Here 20 is equal to 20. So this position is a lower bound position. This is the first position where we can fit a target element. If our target is 30, ignore 10, 20, 20, 20 because here these numbers are smaller than the target element. When we have 30, here it is equal to target element, then here we need to stop. This is our lower bound. If our target is 35, which is not present here in this list of numbers, then what we need to do is we need to compare the target element with the elements of the list. Here 10, 20 and 30 are smaller than the 35. So we need to ignore these numbers. And here this is the first position where the element is greater than 35. So here we need to stop. This is our lower bound index. And in the previous tutorial we used binary search algorithm to solve this problem. First we need to find the middle element. When we take two pointers, low and high, low will point to the first element, that is 0th index. High will point to the next index of the last index. Why? That is because here we are searching for the position, not the element. Remember this. If I take target as 80, what is the output? That is 7th position. Here these numbers are smaller than 80. So we need to place 80 here. So lower bound index is 7. To get that position, we need to take low and high pointers like this. Then find the middle element. 0 plus 7 truncated division 2. So we'll get this as the middle element. Then we need to compare the middle element with the target element. There are three possibilities. Here, if the elements are less than the target element, we need to ignore them. When middle element is less than target element, what we need to do? Ignore them. How to ignore them? That is, search in the right side of the middle element. Ignore this and search in the right side. Take this as the search area now. So that's why when middle element is less than target element, we need to take low equal to mid plus 1. Like this. This is when middle element is less than target element. What if middle element is greater than target element? Or middle element is equal to target element? In both these scenarios, we need to do the same action. That's why we'll combine these two scenarios into one condition like this. When middle element is greater than or equal to target, what we need to do? Let's take target as 30. This is middle element. Here first middle element is less than target element. So we need to take low as this. This is our search area now. Next, here we need to find the middle element, right? So low plus high truncated division 2, 4 plus 11. So here we'll get this as middle element. Now when middle element is equal to target element, this condition becomes true now. Middle element is equal to target element. Then what we need to do is, we found target element in the list of numbers. But here we are not searching for the target element. We are searching for the first position where we can fit a target element into the list without disturbing the sorting order. So we are searching for the position. Here this can be the one of the possible answer. That is, this index can be the first position where we can fit this target element into the list. But it is really the first position? We don't know it. Because here we are using binary search algorithm. Binary search algorithm doesn't search in the sequential order, right? So what we need to do is now, we need to take this as our one of the possible answer and we need to search for the first position in the left side. I don't want to throw mid away. I keep it in the search space and we'll search in the left side. So that's why here what we'll do is we'll take high equal to mid. So we'll take this as a search space now. Again we'll apply modified binary search on this search space. Here we'll get this as middle element. So now we'll compare 30 with the target element 30. Yes, it is equal. What I'll do? I'll take high equal to mid. So I'll take this as one of the possible answer and I'll take this as my high. Here low is equal to high now. When low is equal to high, that means there is only one position left. So we need to stop now. When low becomes high, that is our stopping condition here. So when list of numbers is given, we'll use binary search algorithm. We'll find the middle element and we'll compare that middle element with the target element. If middle element is less than target element, then that means that middle element and the elements present in the left side are smaller than the target element. Because here numbers are sorted in the ascending order. If middle element is smaller than the target element, then the elements present in the left side of the middle element is also smaller than the target element. So we need to ignore that part. That's why here we'll take low equal to mid plus 1. Low pointer will point to the next position after mid index. Now what if middle element is greater than target? If middle element is greater than target, then that means that can be the one of the possible answer. So we'll take high equal to mid. We'll include that in the search space. We'll do the same thing when middle element becomes equal to target element. When low is equal to high, that means only one position is left. That left position is our output here. Here this modified binary search algorithm returns a position. If target is present or target is not present, it will return a position. That position is the first position where we can fit our target element into the sorted list without disturbing the sorting order. Okay, so this is about lower bound problem. That's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.